Senor Paul Coggin. He's an Internetwork Consulting Solution Architect with Dynex Inc. in Huntsville, Alabama. Paul is responsible for architecting and securing large, complex, tactical, critical infrastructure and service provider network. Paul's expertise includes tactical service provider and ICS, SCADA, network infrastructure, hacker attacks, and defenses, as well as large, complex network design and implementation. Please welcome Mr. Paul Coggin.
I appreciate everybody attending this morning, and greatly appreciate the invitation to be at BSides Puerto Rico this morning. This is an awesome opportunity to come to Puerto Rico and share some information with you guys today. So I'm a network guy. My background is routers, telco, service provider. I either am trying to break into somebody's network that can't be broken into, or trying to secure a network or build a network at any given time. And so I've learned a lot of things working on red teams and being on the defensive side about some techniques that a lot of people that are involved with red teams and on the defensive side are not aware of, that can be used against them or used against a target when you're engaged in a project. And we'll throw some ideas out to you, and hopefully you will learn something. How many people are involved with pen testing? Anybody pen testers? How many are router guys? Consider yourself a router guy? Auditors? Okay. Hopefully I have a little bit for everybody in this. So how would you, first, what I want to dig into deeply here is what can you do with the router after you've captured it, say during a pen test engagement, or what an adversary might do to your router if they capture your router. But first, how can somebody possibly get access to your router? One example of how somebody may get access to your router, even if you've gone in and locked down your router, locked down the management plane, how the management of the network is permitted. You've locked down access to, say, a trusted IP address for HP OpenView, Cisco Work, SolarWinds, network management. If I can get access to documentation that tells me what the IP addresses are that are trusted by way of, say, popping a file server and what have you, and find out that trusted IP address that you have specified in your access list on your routers, it could be that I can use a tool like SNMP Blow, which is basically this script here, that I can specify the IP address of the trusted host and combine that IP address with a dictionary attack targeting the SNMP community strings, and run this script against your router and send SNMP UDP packets to that router. And if I'm able to guess the SNMP community string that you have used, when I guess that community string, spoofing the IP address of, say, your network management system, when I hit the good SNMP community string, I'm also injecting in that packet the IP address that I want the router or switch to download the config file to, which will be a different IP address. It's going to be the IP address of the attacker. So I can spoof a trusted IP address and redirect it to a real attacker IP address that's routable somewhere, either on your network or out on the internet somewhere possibly, and defeat the trust relationship that you might have on the network. And the way to stop something like this from happening is you've got to go, just the whole cliche of defense in depth. You've got to go and use both layer 2 and layer 3 anti-spoofing techniques to block somebody from doing spoofing, because they may be coming from the inside, they may be coming from the outside. So you got to make sure that you're doing anti-spoofing, both layer 2, layer 3 on your network. So this is one way that we may get access to your routers. Now, if you go and use this script, if you go download it at the link I have here listed below, if you get that script, the SNMP MIB that it uses is for an older router MIB. You'll have to update it. to use the newer SNMP MIB if you want to go use it. So we've gotten access to the router somehow. We may have popped a Cisco Works or HP OpenView Windows Unix box and have gotten access to the TFTP directory where config files are archived and exploited trust relationships, what have you, SSH brute force, telnet brute force, dictionary attack, what have you, and gotten access to the equipment. We're logged into the router. So what are you going to do with it? In many cases, when I participate on red teams, everybody's popping shells with Metasploit and popping Windows boxes, web servers, getting shells on Unix boxes. They get into a router and they don't know what to do with it. Well, here's some ideas of what you can do with a router. There's a capability called route maps, which leverages access control list on the router. And what that allows you to do with route maps, you can implement something called policy routing. And you can basically override the routing table of the router. So traffic may be wanting to go one direction because of the preferred metrics, whether you're using static routes or dynamic routing protocol like OSPF, RIAD, GRP, RIP, what have you. But with policy routing, you could totally overwrite that and redirect traffic of interest to a different path. So down here at the bottom of the screen, we've popped a layer 3 switch. And by using route maps, we can implement policy routing, and we can go and use an access control list to specifically define the traffic that is of interest to us. We wouldn't want to maybe go target all of the traffic, but we want to go and do a surgical strike and target some specific traffic from a specific host that we want to redirect to do a layer 3 man-in-the-middle attack. So using policy routing, by leveraging the route maps, we can go by way of attacking this router. We can reconfigure the router that the traffic that is of interest to us can get redirected to the host that we have on the network that we have control of, so that we can sniff traffic, we can modify traffic, we can do a denial of service and just drop it in a bit bucket. But through the man in the middle, we could just redirect the traffic of interest to us, override the routing table, redirect the traffic that is interest to us to our attacking system, and then forward it back on out the network, and the victim would never know the better. And we basically enables us to do a layer 3 man in the middle, not the classical layer 2 ARP poisoning with Eder, Cap, and Cain enable. We're doing this with a route map at layer 3. This is not a layer 2 attack. Alternatively, we could in the middle of the screen, we could redirect traffic that is of specific interest to us and exfil it out a backdoor tunnel that we have. Somebody might drop in say a 3G, 4G backdoor modem connection and have only the traffic that is of specific interest to us override the routing table and take the path out a backdoor that we have shown here in the middle of the screen. Or you might an adversary could pop your perimeter router up at the top of the screen, and it may be that we have influence over a certain service provider's network, data center, some kind of cloud-based service, and the victim is multi-home. They got multiple internet BGP connections, for example, but there's one path that we have more control of and influence of because we've popped the upstream provider, and we can go and redirect traffic out of interest. Maybe not all of the traffic, because if you redirect all of the traffic, if they're using something like MRTG, if they're monitoring their net flows, it may show up, they may detect that all their traffic is switched abnormally to a different path. But if you go in and use an access list and you specify only the specific traffic of interest, you might be able to use policy routing to redirect that traffic out a path where you can go and capture and manipulate traffic because you have access in that part of the cloud. Something to consider. You think about.
One question. Where do I run with the route map? Do I run it with IP tables?
No, it's going to be on a Cisco router. This is something known as a Cisco router. You could run it globally as a global command using the policy routing, or you could associate it with a interface the inbound interface. When the traffic hits the inbound interface, you can influence the traffic at the inbound interface, or you can go and configure the router globally to implement the policy routing. The link here I have at the bottom as reference goes into some examples there. And if you want to know more about the route maps and policy routing, there's a book Jeff Dole wrote, TCP/IP Routing Volume 1. He goes into great detail. Jeff Dole, TCP/IP Routing Volume 1. Here's something, a technique that has been known for a very long time. Just want to give you a point of reference. This is where you can use GRE tunneling. Back in the day when I got into networking, we would use GRE tunneling to tunnel AppleTalk, IPX, LAT, DEGNet, etc. across our IP wide area networks. Well, it turns out, using that route map that I was referencing, is if you go in and break into a router, that you could turn on GRE tunneling between the target on the left here and terminate the tunnel to your attacker router, a router that you have control of. You create a GRE tunnel. You can use route maps, as we just discussed, to redirect traffic of interest to your network and capture traffic and sniff traffic over a wide area network. Now, this has been very well documented, and the reference link here at the bottom goes into detail on how to execute that. Now here,
just one thing. You making reference to the screen. You blocking the screen.
Am I blocking?
They set you up. But one question regarding that: are you going to provide a link where we can?
I'll provide the slides to BSides and put it on the web and show you, or you can email me.
All right.
But I'll provide everything. Now, the reason I showed you the GRE tunnel, that's the old school way of doing that tunnel attack. But something that I haven't seen published anywhere in regards to an offensive maneuver is there's a new technique. It's not new, it's been out there for a little while, but it seems to be new for the security community, is ER span. There's a technique that in a Cisco routed network, you could use ER span, similar to use span and RSpan, to do port mirroring. Are you familiar with doing port mirroring on your network? Locally? Well, you can use ER span to exfil traffic out over your wide area network. And that's a great tool in an enterprise for being able to sniff traffic and troubleshoot. It's a wonderful tool if you're on a red team doing penetration testing and you're popping routers and you want to get data exfilled. I spoke with a gentleman earlier that works in the medical industry. Is worried about data privacy. This right here is something. If you're worried about the privacy of your data, not wanting to, if you're under HIPAA regs, etc. This is a technique. If I got a hold of your router as part of a red team engagement, I would use something like ER span to exfil data to our network to show that we can sniff traffic over your wide area network. This is just one example. It's a normal capability that a network engineer would know how to use. But if you're working in a pen test team, you also need to know about this, because it's something that you could use when you're getting access to the routers. Now, from the defensive side, if you're the defender, if you're the guy that's having to defend your network, you're an auditor, you're going to want to make sure that you have NetFlow running on your network, and you're watching for sessions like this trying to run across your network and exfil data, that all of a sudden there's traffic like this being sourced out of your network, and it's going to probably can be pretty voluminous. If it's more of a surgical attack, it could be that they only go after specific traffic and try to make it low and slow. But if you got NetFlow going with good instrumentation on your network, you can capture something like this if it starts happening. The bigger thing is to lock your network down really tight so that nobody ever gets this access. Here's an old school technique for tunneling, DLSW. Any of you guys ever worked with SNA? Anybody ever worked with SNA? When I first got into routing back in the 90s, I built a large network and I learned DLSW, and in that case, what we were using it for was to tunnel SDLC serial connections back to an AS400 mainframe. And what DLSW allows you to do is take SNA type protocols in NetBIOS and tunneling over TCP/IP version 4. The RFCs lay out specifically that DLSW is used to tunnel SNA and NetBIOS. And basically, as you can see in the config here down at the bottom, we're turning on bridging. And you got the bridge groups here. And so you're basically going to bridge SNA and NetBIOS, which are layer 2 protocols, over IP version 4. And what the thing to note with IP routing and with tunneling in this case is if it's not routed on an interface and you have bridging turned on, the protocol will be bridged. Now, if routing's turned on for a protocol, it'll be routed. But if routing's not turned on for a specific protocol, it will be bridged. Say like if you have bridging turned on and you got IPX on your network, if you got a legacy network with IPX, believe it or not, there's still some of that out there. That IPX would be bridged across your network. Same thing for SNA. Well, in this case, I started thinking about this. Since if it's not turned on specifically to be routed, and if you turn on bridging at the same time, the traffic will be bridged, why can we not go and bridge IPv6? Because you have to manually enable IPv6. IPv6 is a totally unique protocol. It's like the IPv6 running on your network is like running AppleTalk or IPX. Totally separate protocol. So if you got bridging turned on and you're routing IPv4, IPv6 will be bridged. Well, why not use, if you get access to a router that has the software, the feature set to support DLSW tunneling, it could be, if you're a red teamer, that you could turn on this DLSW and exfil IPv6 traffic over the wide area network. Your target will never see it coming. They'll never see it coming. They won't know what the DLSW stuff is. And being an old router guys do not like to admit that they don't know something. It takes one to know one. I'll admit it. I've been humbled over the years. I have no pride. I'll admit it. Us router guys, we're the smartest guys in the room. If you don't believe it, just ask us. And if we see stuff in our router configs that we don't understand, we'll make something up. Because the auditors have no clue. 9 times out of 10, the auditors that are looking at the router configs have no clue. And I can say that because I've been on the auditing side as well and worked with auditing teams. I've worked all sides of it and seen this. So if you're on the red team side, you're a pen tester, you get access to these networks, you can pull this out, put it in there, and nobody will ever know it. The only way they might know it is if they got some active configuration management configured on the network, so that as soon as somebody gets access to the router and starts modifying the configs and hits return, there's a log, an event created. It notifies somebody that the configuration's changed. Now, if they have that level of monitoring configuration, then you may have a network guy that has a clue and he's going to jump in on this and see that somebody's done something, but very rare is that the case. Very rare is that the case. This is a technique to know about. This is not documented anywhere. I just came up with this. I talked to Scott Hogg at Hacker Halted last year about this. He actually wrote the book on IPv6 security, and he thought it was a cool idea as well. I spent a lot of time working in the telco space, working in the original cloud, building voice over IP, cable TV, broadband networks for independent phone companies, rural phone companies. I don't work with the AT&Ts and Quest. I work with the small independent guys, about 50,000 customers or less around the country. And one of the protocols that we use, in some cases, and even the big guys use this protocol here, L2TPv3. And what they use it for, what L2TPv3 does, is there's a concept called a pseudowire, where you can logically, think of logically taking an Ethernet VLAN and dragging and dropping it across a wide area routed IP network. Say from, you could have a VLAN in Puerto Rico and terminate that VLAN, say VLAN 12 in San Jose, California, and you could cross a dozen routers, either on your enterprise internal network or across the global internet, and you could drag and drop that VLAN across that routed network, and it looks like it's layer 2 all the way across all those router hops. That's called a pseudo-wire. That's what this L2TPv3 will do for you. And one of the examples what the telcos use it for is for backhauling, say, your PPOE. You say AOL doesn't own all this telco infrastructure that they use to sell you DSL service. What they will do is they will go to a big telco that's doing wholesale, selling their capacity, and you'll buy the service, and you'll have like a PPOE connection on your home router, and your PPOE will get backhauled across the telco network using L2TPv3. Because remember, PPP is a layer 2 protocol, so they can tunnel that PPPoE across this L2TPv3 tunnel all the way back to where their BRAS router is. This broadband remote access server router. It's basically a router, but when you're aggregating PPOE, it's called a BRAS. When you're and so that's what they do for it. You can see you got all these layer 2 protocols being tunneled across IP here. You see you got IP, you got layer 2, and you got IP, and then you got L2TPv3, and then you got PPP and the layer 2 protocol encapsulated inside this IP again. So this is what it's used for, basically to tunnel layer 2 across a layer 3 routed network. So what does that matter for security? Well, what if I pop your router and you have the code in your router to support L2TPv3? This is a way that we might be able to create a layer 2 tunnel from a router that we pop inside your network and terminate that tunnel at the red team router and start launching layer 2 type attacks across a wide area network. It's something else to know about. A lot of people know about the GRE tunneling, but this is another method if you're not that you might not be familiar with, unless you're a hardcore router guy that works in the telco space, or you're working on a CCIE or something like that. You may not ever run across L2TPv3, but the bad guys are researching this type of techniques to use against you. And like I said, router guys, they're never going to admit that they don't know this stuff. It'll be in their router configs for years, and I know that these type of capabilities are being used against people. People are going in and getting hacked. The bad guys are popping your routers. Everybody's running around doing the Keystone Cops maneuver, doing forensics and incident handling on the in-host devices. And they're not looking at the network infrastructure. The bad guys are not only in your Windows boxes and in your Apple computers. They understand. They know you're going to go do incident handling forensics, and you're going to format hard drives and things like that. They're in your routers, and they're watching and laughing as you go spend all your time and all your money remediating an endpoint device. And they're sitting in the core network infrastructure because they popped your account database, and they got your accounts, and what all network guys do, whatever our account is on the servers are the same ones we use on the routers. Well, guess what? They're in your network infrastructure, and they're backdooring that network infrastructure so that when you go and remediate the endpoint device, they can get right back in. And this is a technique tool that you need to be aware of. I'm going to use this one next router I pop. I'm going to use this L2TPv3. And one thing you got to keep in mind, even if you don't have the code feature set to use some of the things I'm showing you, if you have the memory and I have the access to the router, what is to stop me from uploading new code to your router and turning on these capabilities? If you're not monitoring closely the up-down status of your routers, and most importantly, because you might have WhatsApp Gold running and monitoring up-down status. You see that your router rebooted. Do you know that your config's been changed? Are you using Kiwi tools to monitor that somebody's helping you manage your routers now and adding new commands and maybe new accounts? So here's something else to know about. Lawful Intercept. You guys familiar with CLIA, the Patriot Act? It's all, the Patriot Act's all in the news, CLIA, wiretapping. Lawful Intercept is Cisco's nomenclature for IP-based wiretap. This is how you get your network tapped. The telcos have to have this capability. It's by law, they have to have this capability or they get fined every day thousands of dollars if they don't have the ability for law enforcement to be able to come in with a warrant and be able to do an IP-based wiretap. This code is built in to certain feature sets running on network devices. You get it on your 6500, your 7600. All of your routers could possibly have this. If you don't have it, if you have the memory resources, I could upload this code and you could have it when I'm done with your router to run this protocol feature set, Lawful Intercept. But basically what it does, there is it allows law enforcement to come in and tell the network device to forward traffic of interest out to law enforcement on demand without the target knowing that their traffic's being tapped. So you and I may be having a conversation, but a copy of it is going to law enforcement. A perfect copy.
That's how NSA does it?
What's that?
That's how NSA does it?
I have no idea.
Let's ask Edward. Snowden, that is. There's an issue with that in terms of the privacy of the, for example, medical records.
If you're a hospital and I get a hold of your router, I could use this against you and exfil your data, yes.
Right. And now the patients have the right to see which disclosures have been made about their information. So how does that reconcile? Is there a log and then you make the disclosure to the facility itself that certain records were accessed because the patient himself has the right to know by law?
Well,
Under the High-Tech Act, the HIPAA, and the Omnibus Rule that just came out and was implemented on 23rd September, they have the right to know each disclosure that has been made about the records. And in terms of the law enforcement, they have to come with an order, with a court order, and then the doctors, the eligible professional will grant them access. But what you're making reference to doesn't mean that they're making a request. It's just like, is there, I'll take it.
well, they have to have, this is going to be in the telco infrastructure, and they would hit the telco with a warrant that there are specific traffic flows that are of interest to them, and they would serve the papers to the telco, and then they could go in and as long as they've done their paperwork, they could come in and pull traffic. Now, the whole regulatory piece with HIPAA and stuff, I don't know. I'm not a lawyer. I don't get into that. All I'm focused on here is this. What I'm going to show you is what is as a red team. If I'm coming after your network, because I want your patient database, because I want to do identity theft, I'm not worried about whether you're under HIPAA or anything like that. Or I'm going to show you what you need to be defending yourself against, because somebody going after you legally is going to be upstream from the medical organization. They're going to be in the telco catching traffic. The telco infrastructure as it flows using these methods. But an adversary is going to go after your specific router inside your network and either use it.
This is required by law enforcement to be implemented in the infrastructure in order to comply with.
Only for the telcos, service providers. Only not for the medical field, but only the telco service providers.
Right, but in terms of doing that, and perhaps I can take this subject later on.
Yeah, let's talk offline. We'll see how much time we got.
If you have questions, I'm from Cisco and actually I help you with that. So there's a little bit more into this. So it's not like somebody is actually going to use the router and all of a sudden you're actually going to be able to see.
Right.
It's not like the actual real ninjas out there. They encrypt the traffic, you're not going to see this stuff.
Right.
More of the things that we're gonna be seeing here, if somebody actually, I don't know, kidnap your daughter and is putting stuff here, online regarding that incident, the law enforcement actually can go specifically for that user. And
Right.
and this is not only in the U.S., it's actually, as a matter of fact, there's some regulatory compliance issues outside of the U.S. that are a lot more strict. They actually own your device. They have basically what you think about the root password of the router, which is enable password. So you don't even need this.
Right. So, and to get to the point, just talking about going after a specific source, one of the things that we do with the telcos, it is something you guys are involved with enterprise should know about. Some enterprises are against DHCP. The network guys don't like DHCP because we can't track the IP addresses. We don't know who's going around their network. But there's a capability called Option 82, and we use it in the telco space so that when, say, a DSL modem, some kind of broadband subscriber, they might be on a fiber to the home connection. When they come online, what happens is when they send that DHCP request with Option 82, the network device, and this works on your Cisco switches as well, down to the lower end model switches, it will inject into that packet, that header, the chassis name and the physical interface that DHCP request is coming from. And then if you have a DHCP server that supports Option 82, it will log that. So you have accountability and you can track down that IP address based on the time of day it used that IP all the way down to its physical location. So there's accountability. You don't have to go and use arcane static IP addressing in your environment. But we use it in the telco space because the telco's got to be able to go back into their customer account database and go straight down to where the customer is, because you don't want a SWAT team kicking in the wrong door because of an IP address being misidentified for who was using that. So how would it be used? Somebody could pop your router and enable a lawful intercept infrastructure. Now this is going to be somebody that's very sophisticated that uses this. It's going to be somebody very sophisticated, but they're out there. And your router is going to have features like the Cisco TAP, 2 MIBs, and it's going to leverage SNMP v3. But if they can get a hold of your router because you have not gone and done proper security of your router, lock down the control plane, your network protocols, lock down that trust relationship of who's your router going to talk to for your routing protocols and your switching protocols, lock down that management plane of who can access that router for management purposes. You got to granularly lock it down from the perimeter all the way down to the access layer. Lock down those trust relationships. Because if you haven't done that, somebody that's sophisticated and gets a hold of this router, they can go and either use the code that's built into your router or upload new code and possibly enable an infrastructure attack so that they can redirect traffic using leveraging lawful intercept to their host device. And you would never know that traffic's being exfilled using lawful intercept. Here's a scenario came up with. We were going against a pretty sophisticated network, very, very large, complex network. It was a cloud-based service. They were getting a multicast service, in this case, cable TV, IPTV multicast video. And so you have a cloud-based provider that's providing a multicast video stream to a customer that is turning around and feeding that hosted IPTV service back out into their infrastructure here. And so they have all of this cable TV infrastructure. And in the cable TV world, they call what the enterprise calls a data center. The telcos may call it a data center, or depending on the telco, they might call it a central office. But in the cable world, they call it a head end. And in this head end, you got your billing systems and your middleware and encoders. And so they got this cloud-based provider that's sending them a multicast stream into their head end, and they're turning around and shooting that back onto their infrastructure, out to their customers. And the way multicast works, there's a rule with multicast that a router will not forward multicast traffic if it doesn't have a route back to that source. And so with how this network here on the right, this head end was configured, is the route internally was pointed back to the head end, to the cloud-based head end, because of the reverse path forward rule for multicast. And what that meant is I discovered, is there was, after we were engaged in a pen test engagement, working on a red team, and we wanted to go out to this network and hack it and prove that we could go and touch this cloud. Well, all we could do is we were able to go and hack this router here on the edge of the network, got to that perimeter, and looking at that router, we could see all of these devices. We could see all this infrastructure. And you start looking at MAC addresses, and you start figuring out the vendors, that there's, Solaris box, Sun boxes, and Dell, etc., based on the MAC addresses. This is a really rich target environment, but we can't get anywhere past this freaking router. We can't get two-way connectivity. What we discovered in the process is we enabled NAT here, and by enabling NAT, and enabling some new IP addresses and enabling NAT here, we were able to use NAT to proxy a connection from the external interface into this network and establish a two-way connection via NAT. NAT would proxy our connection for us. So, because these devices on the right in that head end, all of their outbound traffic was headed back toward the cloud. But since they were local to the internal interface of this router here, it was just one hop right there. They're on that same common LAN. We were able to come from outside the network, hit this NAT configuration, and establish a two-way connection and start popping boxes and doing old school Solaris stuff. I'm talking about some old school Solaris stuff because the thing that you learn about these networks here, if you ever get into these old head ends, these things get built, they don't get touched. You get this stuff working, you get the integration working, you got a dozen vendors. Every piece of software, every piece of hardware has got a unique vendor. I got a presentation, a talk I do, I call it the vendor persistent threat. Because all these vendors also have back doors, but that's a different talk. But they get this stuff in place. Nothing changes. The passwords and things are the same wherever you go. And so we were able to go and spread influence once we were able to get access to the management plane of this router. The management plane was not locked down. Ain't a problem with the router. The problem, that's the key thing with this talk. There's not a problem with the network devices. It's the configuration. We're all going to the CCNA. I don't know what's happening. But we go take a CCNA class, or we go take classes, and we learn how to turn on VLANs. We learn how to turn on routing. But what about those whole modules where we learn how to go and lock down the control plane, lock down Telnet SSH, which don't use Telnet by the way, but we don't lock down the SSH access. We don't lock down our SNMP access and lock that down. Well, if you don't lock it down, somebody else is going to pay attention to it for you, and they may actually secure it for you.
Where was that router located?
It was at the edge of a data center connection.
No firewall at all?
What's that?
No firewall?
No, they were using the router for all of that. Yeah, there's a whole lot more to this story that I can't go into. There's a whole lot more to this story, but understand, this is, but basically using the NAT, we were able to establish the two-way connection. And the key takeaway is you got to lock down this infrastructure. Everybody's worried about the endpoint devices. Everybody's, it's all about endpoint devices, but we're ignoring the network. And what's driving me nuts is you have all these capabilities. You got a very, very rich feature set that you've paid for that's not being used. It's the capabilities to lock these networks down, to kill this horizontal and vertical pivoting. You've already paid for it. You don't need to go buy yet another box. I wish right now everybody would quit buying boxes. Don't buy anything else until we go and lock down our switches and routers and use the features and capabilities that we already have for port security. VLAN access list, private VLANs, and lock down the layer 2, layer 3 pivoting before we buy another box. Until we do that, why buy more boxes? Because the bad guys are just going to own that box too. And I sell boxes. So OSPF, whenever we go out and do pen testing, if a routing protocol is being used, if it's not EDGE, it'll be OSPF. If you don't know OSPF, OSPF is an internal routing protocol. And basically how you break it down, you have to have an area 0 defined, and if you have a large enough network, you may break it out into, to segment your network out. You might have other areas, but all the other areas have to touch area 0. And if you have routers that touch BGP and the internet, that's going to be what they call an ASBR, your Autonomous System Border Router, where you go and talk to external networks. And where your area 0 touches other areas, say area 1, those routers are called area border routers. And I got a link here to, if you want to know more about OSPF. Again, that book I referenced earlier, TCP/IP Routing Volume 1 by Jeff Dole, that's the Bible on this. If you want to know more about this, I highly recommend that book. So whenever we plug into a network in a red team engagement, routing protocols are being run, OSPF, in a great deal of the cases will be active on the network. It's never secure. Never, ever secure. There's no authentication. The authentication is available. Clear text and MD5 are available. If authentication is found running on the network, it is clear text for the love. If you're going to go through the trouble, if you understand that you need to go and do authentication of the protocol, why would we not go and use MD5? I mean, for real. If you understand the need for I don't know what it is, but I'm telling you, we go out and we see clear text if we see authentication. And you just pull up Wireshark and you just see it. It's this low-hanging fruit. If you're working red team, you need to know how this works because you're leaving stuff on the table. We're going behind other pen test teams and going in and auditing their networks, and this is never hit a report. You want to be a rock star on your next pen test engagement? Go in and target the routing protocols. It's never been touched. It'll be a whole new. You'll be a rock star. So what can you do? What can you do if you go and say a protocol like OSPF, and you're doing an internal audit, pen test, you've got access, and you see OSPF being advertised out on the wire unauthenticated, or it's using clear text like it is in 99% of the time. What can you do with it? Well, you could turn up. You can use one of these tools I have in this box here. There's a long list. You can use Quagga, or even go and pull up G3SN with Dynamips, fire up iOS, boot it up in a VM, integrate into the network. Act like a Cisco router, and you can inject new routes into the network so that you can enable man-in-the-middle type attacks. What about injecting routes and advertising Google, Microsoft, Yahoo, the PLA IP addresses out of Romania or somewhere? Inject those into the network and use those IP addresses as the source of all your attacks. Because they may be really good endpoint desktop server guys, and they may have Splunk and things running. They probably haven't looked at the routers. They probably haven't turned on flow yet. They probably don't have good routing logs yet, especially if you're able to do this type of attack tool. Start injecting those in. They're going to be on the phone hollering at Microsoft and somebody in Romania, and you're on the inside of the network the whole time. It would be so fun. I'm going to do that to somebody. I've got to do this. Just because I got to do it. It'll be a great talk. You can add new routes to the network. You can do a DOS. One of the tools I want to call your attention to, Naval Research Labs. It's a government agency, Naval Research Lab, as in U.S. Navy. They have a research lab, and they have a tool called CORE. It's a network simulator called CORE. I forgot what CORE stands for. But it is awesome for simulating networks. It basically fires up a bunch of Quagga servers in a network environment where you can mock up and simulate, say, a BGP network all on your desktop in, say, a VM environment. And if you want to learn network protocols, that's a good tool to learn with. But you could use that core to do these attacks I just mentioned. If you're an auditor, please go and start addressing these protocols because they're being overlooked by all of your other auditor peers. Everybody's talking about BGP here lately, and then all the BGP hijacking is happening. You know, there is traffic being redirected to Iceland. There's games being played with BGP out of Turkey now, where the Google DNS is being hijacked. The IP's prefixes for that's being hacked. So here's how the BGP works. If you're not familiar with BGP, your telco, they have a number called an autonomous system number that uniquely identifies them out on the internet. BGP is the protocol that the internet uses to route between all the different organizations out on the internet. If you're multi-home to the internet, you'll be running BGP if you want to do load balancing and active failover. So like I said, everybody's going to have a different AS number tied back into in between each other. And it's based on a trust relationship. Now in the U.S., these trust relationships are very locked down. You deal with a telco in the U.S., my experience, they're very, very granularly controlled. If you're AS2, they only let you send routes, advertise routes to say AS1 here, if they know that you own those routes. They very granularly control if you're a spoke AS organization. But if you're one of these peering organizations that's trusted, like say if you're a major tier 1 telco, they may be accepting everything you send because you're one of the backbone core organizations in the world. Say China Telecom here. But what could happen because of the trust relationship that is required with BGP, people can go and inject, they can go do things. Now, this first attack I want to call you out to is like I said, I run around rural America dealing with the independents and going to colo facilities and places where there's cross connects between multiple organizations. One thing you see is you get to some of the colo facilities where multiple telco service provider organizations come together to interconnect their various networks. And in some cases, they may have a layer 2 switch where that's common for a lot of different connections where people connect to so that they can establish a layer 3 connection for, say, BGP. And I've been in some facilities where there's gates and guards and guns and very strict access control. I've been into others where you're like, oh my God. I can't believe that it was so easy to get into this facility, and then you freak out when you get in, and you literally see cabling coming out of racks along the floor, and you're stepping across it to get over to your rack, to your customer's rack, to work on, say, I'm seeing this in my mind because I was in one of these networks working on some optical equipment, and I had to step across this cloud provider, voice provider stuff, and it was just this huge rat nest coming out of all these racks. Well, you have all these cross connects happening in a facility, and they got these layer 2 switches. One, you got the physical control. If there's no mind to the physical control and physical access and making sure that things are really tight and you know how things should be connected, there's probably not much mind to the network management access. If you can get that access to that network, why can you not go and use something like ER span if you were to go and get into that cross connect switch and mirror traffic out to some place out on the wide area network across the internet of whatever traffic is of interest to you? Why not? Or use Lawful Intercept or some other tunneling method so that you could get remote access and do layer 2 attacks right there on a core aggregation connection. Now, what you're seeing in on the web with like the hijacking of the Google prefix, and there was a hijacking out of Pakistan of YouTube, Facebook got hijacked, There was some hijacking happened a couple years ago out of Southeast Asia. Basically what happens, so you might have this autonomous system 6 and autonomous system 4, and they're communicating with one another. There's nothing to stop, because of the trust relationship the internet's based on. There's nothing to stop somebody, say, from AS5 here, say Turkey, from hijacking, say, a Google DNS IP address and advertising that they own that IP address into the network. Now, they're not going to be able to influence the whole internet, but whoever they have better metrics for in BGP, they will be able to influence that traffic. And by way of doing that, be able to gather intel. They could block traffic, just capture it, maybe modify and inject, depending on how much traffic they're capturing and what their capabilities are for dealing with that traffic. And one of the rules that you have to learn when you get into routing is the longest IP prefix wins. Now in BGP, we typically try to aggregate and summarize as much as we can the IP blocks. But when you're doing this hijacking, and if you own the ASs, if you have access to the ASs, you can advertise whatever you want to. Now good practices is to summarize, but you could go in and put that really long prefix, like what's happening with the Google stuff out of Turkey, and cause a hijack like this. Now, another attack you could do with BGP, and I haven't read where this is happening, is you also could hijack an AS number along with the IP address. If you're working, if there's state-funded organizations, if you have a government, a country coming against you, and they want your traffic, there's nothing to stop them from, the telco will cooperate with that country that they're hosted in. It very well could be that they, not only could an IP prefix be hijacked, but the AS number be hijacked as well, similarly. Now, one of the thoughts that I want to throw out to you, I'm working on a presentation on this. In the networks that I build, where we roll out telco core networks, we roll out MPLS, and in those MPLS networks, we build one big network, one big 10 gig network, maybe with multiple 10 gig pipes across the core infrastructure, and we'll use MPLS to carve that network up into multiple VLANs, and we'll run voice, video, internet, private network services, and carve that all up on one infrastructure. MPLS is wonderful for doing that. The thing is, it's in my mind, whoever's doing this hijacking of these BGP routes, let me throw this out to you, because I haven't seen this out in the anybody talking about this yet. If you have access to these BGP routers, whoever's doing this hijacking, what is to stop them from going and influencing your MPLS private VPNs and injecting routes, leaking traffic out, introducing new networks into your MPLS network. If you have an MPLS VPN network, don't listen to the sales guy from the telco that the MPLS VPN is secure. You better be taking responsibility for your network. We keep talking about privacy. If privacy is important to you, put a VPN on your device and build a VPN. Cisco's got. I'm a Cisco guy. It's my Kool-Aid I like to drink. They have you can use numerous VPN architectures for securing your MPLS network. So make sure if you're using MPLS, especially outside the U.S., if you're doing international business, you want to be doing VPNs, encrypted VPNs. VPN does not imply encryption. So I believe that they're being hijacked personally. Any questions? Well, I hope y'all enjoyed the talk and got something out of it.